In the last section, we were looking at dimensional analysis, which was converting from one unit to another. And in the last section, we were looking at English to metric conversions. Now, usually what we're going to be doing is performing conversions within metric units. So what we'll need is this table down below. Now, the table down below lists the different prefixes that we use for metric conversion. I would suggest strongly memorizing all of these because the AP test might tell you you've got kilometers or decimeters or kilograms and expect you to know what that is, and they'll just assume that you have these memorized. However, if you don't memorize all of them, the ones that I would super suggest knowing are kilo. Kilo stands for 1,000. So what that means is if I have, for example, 1,000 grams, I have 1 kilogram. Deci is 0.1. So what that means is 0.1 grams equal a decigram, or 10 decigrams equal a gram. Centi is 0.01. So 0.01 centimeters is, 0.01 meters is equal to a centimeter, or I've got 100 centimeters in a meter. Milli is 0.001, so 0.001 meters make up a millimeter, or 1,000 millimeters make up a meter. And then nano will be super important when we talk about light. Nano is actually 10 to the negative 9th, so 10 to the negative 9th meters equal 1 nanometer. Okay, so I would memorize at least those, but I would really suggest strongly memorizing all of them. So here we've got a conversion, and it's a little more tricky than the ones we've done before. So we're told the speed limit on many highways in the United States is 55 miles per hour. Now, whenever I see the word per, I know that it means divided by. So I've got 55 miles per, or divided by, 1 hour. Okay? What will be posted in kilometers per hour? So I'm still staying in hours, so I don't need to do anything to this. I need to change miles to kilometers. So step 1. Now this is going to look exactly like what we've done before because I don't need to change hours. I'm only changing miles. So I start with miles up top. I need to make miles go away, so it goes on the bottom. Well, if I look over here, they tell me 1 mile, so I put 1 by mile, is equal to 1609 meters. So step 1, I change miles into meters. But that's not going to get me all the way to where I need to be. I need to change to kilometers. So I need to keep going. So I need a second step. This time, I need to make meters go away. So meters is going to go on the bottom. I'm changing it to kilometers. Now note, in this example, they don't tell me how many meters are in a kilometer. They expect me to know, and that's the way it'll always be for those metric conversions. So, if I look back, kilometer is 1,000. So I know that I've got 1,000 meters in every 1 kilometer. Okay? Now, even though there are multiple steps, it looks exactly like what I was doing before. If numbers are on top, we multiply. If numbers are on bottom, we divide. And it doesn't matter what order I put these in, as long as if something's on top, I multiply. If something's on bottom, I divide. So 55 divided by 1 stays 55, times 1609 divided by 1 times 1 divided by 1,000. Now if I plug this into my calculator, what I should get is 88.495. But I have to keep track of significant figures. My measurement started with 2 significant figures. 1, 2. I'm going to cut that off there. Now remember, I only look at the number directly next to where I cut it off. So this is going to become 88. This 4 doesn't change this, so it just stays 88. I need to keep track of units. My miles went away. My meters went away. I'm left with kilometers per hour. So I would drive at 88 kilometers per hour. Okay? So take a second to solve example 2. Now you're told that you've got 15 kilometers per liter. Okay? Now you're changing it to miles per gallon. So this is going to be a little bit tricky. You're going to have to decide what you want to change first, kilometers or liters. When you're changing liters, I'll give you a hint, because this is already on the bottom, if I want to make liters go away, I need to put liters on top to cancel that out. Okay? So take a second and try to solve example 5. So what you should have seen, I've got 15 kilometers per liter. I already put my liters across from each other. They tell me 1 gallon is equal to 3.79 liters. So I'm going to take this liter and put 3.79 next to it. Okay? And then what I'm going to do is 3.79 liters is equal to 1 gallon. Well, now my liters will go away, and I've got kilometers per gallon. I want miles per gallon, so I need to keep going. So I've got kilometers on top. In order to make that go away, I need to put them on the bottom. Well, I know that I can change kilometers to meters. And I know that there are 1,000 meters for every 1 kilometer, because I've looked at my table on the front and I know kilo equals 1,000. But I still am not done. I've got meters right now, and I want miles. So I need to go one more step. So since I've got miles on top, meters on top, I need to change and put meters on bottom, and I need to change it to miles. Well, in the last problem, I was told 1 mile is equal to 1609 meters. So when I plug this into my calculator, numbers on top, I multiply. Numbers on bottom, I divide. So 15 times 3.79 times 1,000 divided by 1609. I'm ignoring all of my ones because I know they don't change anything. So I get 35.3325. Again, I can only keep 2 sig figs, 1, 2. The 3 does not cause it to round up. So I'm going to have 35. My kilometers went away. My liters went away. My meters went away. So I've got miles per gallon. Okay? So conversions are going to be super important. we're going to change units all the time, and it's always going to be the same setup. Whatever your units you're trying to make go away need to be opposite each other so that they can cancel out, okay? So in temperature, there are 3 different units for temperature that we're going to be concerned about. The first, and I always spell this wrong, is Fahrenheit. Fahrenheit. That's what we use in the United States. That is not what we use in chemistry. You will never see it in chemistry measurements, okay? The second is Celsius. This is what our thermometers will actually measure in and what we will usually use. The third is Kelvin, which is an absolute scale, which is really what we'll need for gas laws. And we'll talk about what it means when we talk about absolute later and when we get there, okay? Now, when we talk about Celsius and Kelvin, the size of 1 degree is the same on Celsius and Kelvin. These two are really easy to change between. What you do is you take your degrees Celsius and you add 273.15, and you'll see me usually just add 273 to get close. But 273.15 plus your Celsius gives you your Kelvin, okay? So it's the exact same scale. They're worth the same amount, but Kelvin's going to always be 273 degrees higher, okay? Last thing we're going to talk about really quick is density. Density is the amount of matter in a given amount of space, which means the amount of mass per volume, or m over v, okay? Now, if you'll look at the table below, you'll notice that the table gives you densities for certain substances. The reason that they can do that is density is an intensive property. And what that means is it does, not depend on how much. So if I have 1 gram of gold, or I have 100 grams of gold, the density is always 19.32 grams per centimeters cubed. If I have liquid water, it's always 0.998 grams per centimeter cubed. Doesn't matter if I have a little bit of water or a lot of water, it's always the same. So intensive properties do not depend on how much stuff. Extensive do. Okay? So extensive properties would be things like mass or volume, because as I have more stuff, my mass gets bigger. As I have more stuff, the amount of space it occupies gets bigger. So extensive properties depend on how much stuff. Intensive properties do not. Okay? So make sure you know how to calculate density. Make sure you know how to perform unit conversions. These are going to be important.